So a man of mass small m is standing at one end of a stationary floating barge of mass 3m. So let's draw the barge first. So let's assume this is the barge. And then we have a man standing at one end of the barge, right? So we'll draw the man at one end of the barge. So let's say this is our man standing at one of the ends of the barge, right? And the mass of the man is m. Mass of the barge is 3m. And then since in the center of mass of the barge will be at the very center here, right? So this is 3m, and then the length of the barge is capital L, right? So the first thing that we will do is we will first pick and choose our reference point, right? So in this case, let's assume that the center of mass of the barge is our reference point, right? So what we'll do is we can draw our x and y axis like this, right? And so this is our reference point, and let me this is my reference point, and I'll so this is my y-axis and this is my x-axis, right? So the core concept here is, since no external force is acting on this man and the barge system, the center of mass won't change, right? It won't move, right? And that's the core concept here, right? And let me mark this in a different color so that I can see this. Yeah, right? Right. So the very first thing we'll do is we will calculate the center of mass of this system, right? So x center of mass will be nothing but using this as my reference point, right? So I'll take the mass of the barge 3m multiplied by the x coordinate of the center of mass, which is 0, plus mass of the man multiplied by the x coordinate of the man, right? So in this case it will be L by 2, 0. This end will be minus L by 2, 0. So I'll multiply this by L by 2 divided by 3m plus m. So this becomes 0. So my x-com turns out to be, m will cancel out, L divided by 8. So my x-com will be L by 8, right? Now the man is moving from right to the left, and the man moves to the very end of the barge, right? Now, as the man moves, since there's no, again, external force acting on this system, right, the center of mass of the system will not move, right? So right now, the center of mass of this system is somewhere here, right? With the coordinates as L divided by 8, comma 0. The x coordinate is L divided by 8 and the y coordinate is 0, right? Now as the man moves from right to left, the barge will move from left to right, right? So let's say as the man moves, the barge moves a distance. So the man, when the man reaches the end of the barge, so this is the end of the barge, right? And then when the man reaches here, let's say the barge has moved by a distance x towards the right, right? Which means that the center of mass of the barge would now be somewhere here at a distance x from the origin, and the distance of the man from this reference point would be negative L divided by 2 minus x, right? So now then we can now calculate the new center of mass of the man and the barge system, right? And what will that be? It will be 3m multiplied by x plus m multiplied by L by 2 minus x, and this will have a negative, right, since it's on the left hand side. So this plus will become minus here, right? So my x center of mass comes out to be 3m x minus m into L by 2 minus x divided by 3m plus m, right? Which makes it, the m's will all get cancelled out. 3x minus L by 2 plus x divided by 4 will be my center of mass, and this has to be equal to L divided by 8, because my core concept is that the center of mass is not changing, right? Because there's no external force acting on the system, right? So with this, what I can find is the value of x, right? So this turns out to be 4x minus L divided by 2 is equal to L divided by 2, which makes it 4x is equal to L, and x is equal to L divided by 4. Right? So now as that man moves from right to left, the barge will move a distance x left to right, right? And that's the value of x, right? And this is the answer of the for the first question, right? How far will the barge move, right? So the barge moved by a distance x, and that distance is L divided by 4. So this is the answer for A. Now when we look at question number B here, right? Let's go back and check the question. If the man walks at an average velocity of v, what is the average velocity of the bar, right? Now, since there is no external force acting on this system, the momentum momentum of the system will be conserved. Will be conserved, right? So now, so what is the momentum of the man? P man is equal to mass of the man multiplied by velocity, and based on our reference point, the man is moving in the negative x direction, right? So this will be minus mv here, right? Now, what is the p of the barge? So rather than p of the barge, now let's say the barge is moving with a velocity v of barge, or let's call it vb, right? So my vb is the velocity of the barge. Now, one thing that we need to keep in mind is, since the man is standing on the barge, right, the man is also moving at a velocity vb along with the barge, right? So the total momentum of the man plus barge system will be m plus 3m multiplied by vb, and this will be plus, right, because the man is moving with the barge, right? So now what we can do is, since the initial p initial was equal to 0, my p final will also be equal to 0, and my p final is nothing but m plus 3m multiplied by vb minus m times v. This is equal to 0, which gives me vb is equal to v by 4, right? So this is the answer. So this is the velocity of the barge, right? So the concept is slightly confusing here, right? Because we have the man moving with a velocity v, but then since the man is standing on the barge, right, the man will also be moving along with the barge with the same velocity as the velocity of the barge, right? And that's where, when we apply the concept of conservation of momentum, we will have to factor in the man and the barge as well moving with the velocity of the barge, right? And that's how you get the value of VB. I hope you got the concept. Thank you.